let's look at some of the optics of the human eye. The human eye is really complex, and there are very many things that are right with it and can go wrong with it, but we'll only focus at some of the things. We always like to simplify physics, so we'll just look at some of the issues with the eye. So first of all, a healthy eye sees clearly in a certain range. So if I were to draw here the eye, we know that there is a point at which the eye starts seeing things clearly, and theoretically the healthy eye can see all the way out to infinity. But in reality, we know that the farther the things are, the smaller they get, so at some point they'll just become a dot and the eye can't really see them anymore. But we still consider, the eyesight to be perfect starting from this point called the near point all the way to infinity. Now, if we have another kind of a healthy eye, so you go to the eye doctor and they tell you that your vision is 20/20. What that means is that you see at 20 feet what you should see at 20 feet. So we're only looking at a narrower, a shorter range from what we call the near point all the way to the far point. So a healthy eye sees clearly in this range, and then it becomes fuzzy everywhere outside that range. So again, the near point, this thing, is how close to the eye an object can be brought and still seen clearly. The far point is how far away from the eye an object can be placed and still seen clearly. Now, there are multiple eye defects. We will look at some of the ones that we can explain using optics. So one of the eye defects is that the eyeball is too long. So the image is not formed on the retina, but in front of it. So an eyeball that's too long, so let's draw an eyeball like this. Instead of the beams of light to come in here and form on the retina, they form inside the eye. So I should have bent these beams somewhere else. Now, in reality, we think about the eye as having one lens, but there's so many surfaces where refraction occurs. So where I bent these beams doesn't really matter that much, because there's the aqueous humor inside the eye that also acts as a lens. So we have this lens, we have mirrors, the cornea, and so on. So the point here is for me to show you that the image is formed here instead of it being formed back there. So that's why we say that the eyeball is too long and the image is formed in front of the eye. Another problem with the eye could be that the eyeball is too short. So if I draw the lens and a squashed eye like this, then the beams of light that come will intersect somewhere back here and form the image behind the eye instead of forming it on the retina over here. Now, the long or short shape of your eye isn't the only thing that can go wrong. It's possible that the muscles that operate your lens are not strong enough and they don't push on the lens to make it more curved or pull on the lens to make it flatter. Those kinds of things can also happen. Also, the older you get, the more rigid this lens becomes, so you can't stretch it or compress it as much anymore. So there are multiple defects, but it's commonly thought of, eyeball being too long or too short when you're young, and that's why you have various problems. So to correct eye problems, we use glasses or contact lenses. And for the nearsighted eye, so let me draw the nearsighted eye here. Actually, I start with a healthy eye. So this is the healthy eye. It sees from the near point to the far point, but then the nearsighted eye sees the near point in the right place, but it only sees up to this distance. So to correct this, we give the nearsighted eye diverging lenses. Then the farsighted eye will need converging lenses. So here we have the healthy eye again, and the healthy eye sees from the near point to the far point. The farsighted eye sees far away but doesn't see close up, so it may see from here to here rather than closer. So if you place something inside where a normal person can see, a normal eye can see clearly, if you place an object here, it doesn't see it clearly. So we have to give this person converging lenses so that the person can see clearly. So how really do these glasses work? Glasses or lenses form virtual images that the naked eye can see. So the principle that we're using here is that for which we have to deal with multiple lenses, multiple optical instruments. And remember that the object will pass through the first lens, and that lens will form an image. Well, this new image will become the object for the second lens. So in reality, light passes through the lenses almost instantaneously. But to simplify the physics, the way we think about it is we take each lens individually. First, we deal with the image of the object in the first lens, and that image becomes the object for the second lens. So let's look at the glasses and how they work. So we have the healthy eye, and it has a near point and a far point. So everything in here is seen clearly. So this is clear. Everything else is fuzzy. Now, for the nearsighted eye, here is a nearsighted eye, and for the nearsighted eye, the near point is fine. It's actually usually closer to the eye than the near point of a healthy eye. But the far point is somewhere closer. So the nearsighted eye sees the near point, but things that are any farther away than this location become fuzzy. So I didn't finish writing FP for far point, NP for near point. So then the nearsighted eye is going to get diverging lenses which do the following thing. So let's say that we're placing an object here where the naked eye can't see it. The lenses will produce an image of this object, and remember that diverging lenses always produce virtual images, so there is no question what type of image this will form. And remember also that virtual images are in front of the lens, on the same side as the object. So then the image that it forms is going to be somewhere here, where the naked eye can see it. So technically, we have an object. I guess I should write that here. Object, image, through glasses or contacts. Okay? So this object is going to pass through the first lens of the glasses or the contact lenses and form an image where the naked eye can see it. Then this image becomes the object for the human eye, and it's placed at a good distance from the eye so that the eye can see it clearly. Now, in reality, it's not that light bounces back and forth and forms images. The eye looks straight through the lens and sees the image at this point. So it just happens in one fell swoop. But to explain this in physics, we first look at the object through the first lens, and that displays an image in front of the eye and in front of the lens that the eye can see. Okay, let's look at the farsighted eye. So here we have a farsighted eye, and the farsighted eye can see just fine far away. So here is the far point, but the near point is somewhere there. So if we place an object here where the other people could see it, the eye this farsighted eye cannot see it clearly. So then we have to give this person converging lenses, and what these converging lenses will do is place a virtual image where the naked eye could see it. So remember that in converging lenses you can get two types of images. You can get both virtual and real. Well, for glasses it doesn't make sense to form real images, because real images would form back here all the way through the lens, and then the eye can't see them anymore. So we want virtual images that are formed on the same side as the object so that the naked eye can see it. I should mark here, this is the object and this is the image through glasses. So let's do that one more time. We have an object that the naked eye cannot see. We place converging lenses in front of the eye with a certain power so that the object passing through this lens will form an image where the naked eye can see it. And then the naked eye will have to only focus at this place where the image is clear for it. So when you go to the eye doctor, you get a certain prescription for glasses. So they have to correct for your particular near point or your particular far point. And usually the doctor tells you that your vision is, I don't know, 20/20 or 2400, and I don't even know, random numbers. But there is actually a scientific unit for the glasses, and we talk about the refractive power of a lens. This refractive power is measured in diopters, and the refractive power is equal to 1 over the focal length of the lens when the focal length is measured in meters. So if you're told that your glasses have refractive power of -3 diopters, what that means is that you have a focal length that's 1 over that. So focal length is -1 over 3, and the unit for this will be in meters. So since you get a negative number here, a negative number for a focal length means that you are wearing diverging lenses, so you are nearsighted or myopic, and then the 1/3 is how curved your contacts are or how curved your glasses are. So -3 diopters tells you negative that you have diverging lenses, and the 3 diopters tells you how curved your lenses are. If your prescription is positive, that means you're wearing converging lenses, and those correct for farsightedness.